Let's start with just a general curve here, and we're going to talk about the tangent lines to this curve. So a tangent line is a line that touches the curve but does not touch any nearby points on the curve. So if we were to choose, say, this point right here on the curve, a line that just touches that single point is going to look something like this. Comes in, touches the curve, but does not touch any nearby points. If we were to choose this point right here, our tangent line would be horizontal, roughly horizontal. And let's say we chose this point over here. There are many different lines that we could draw through this point, but there's just one line that comes in and touches the curve just at that single point. So our tangent line might look something like that. Now, one of the most important questions in calculus is to figure out the slope of the tangent line. So we could call it m tan, just representing slope of the tangent line. As we go further in calculus, it's often called f prime of x. So let's say this curve here is called y equals f of x. F prime of x just represents slope of the tangent line to that curve. And moving further into calculus, it's also called the derivative. So the derivative of our function f of x. All just different ways of describing the slope of the tangent line. So let's draw a picture here of another just generic function. Maybe it looks something like that, and let's give it a name. Again, let's call it y equals f of x. And we're going to try to explore the idea of the slope of the tangent line. So to start off, let's look at two different x values. And we want to make sure that these are nearby x values. So let's call the first one x. And the second x value, let's call it x plus h. And to represent the fact that these x values are nearby, we want h just to be a small number. So h is a small positive quantity. You can imagine a value like, say, 0.1 or 0.01. Those would be good values for h. So let's take a look at the 2 points on our curve that have these two x values here. And we're going to try to understand the slope of the line segment that joins these 2 points. So nearby points, this line segment almost looks like the curve itself because these x values are so close together. All right, well, in order to talk about the slope of the line segment, we're going to need to figure out what the y values at these 2 points are. And the only thing we know about our function is that it's called f of x. So if we wanted to talk about this y value down here, we'd take our x value, x, put it into our function, and we would have f of x. So that's our y value for this first point over here. Y value for a second point, so right about there. And the y value is what we get if we take this x value here, the x plus h, and plug it into our function. So the y value is actually f of x plus h. And now that we know both of our x values and both of our y values, we should be able to write down a little formula for the slope of our line segment. So we're going to think about slope in the usual way, just as rise over run. So if we look at the rise of our line segment, it's f of x plus h minus f of x And if we divide that by the run is going to be x plus h minus x. So there's just a little bit of simplifying we can do here. We can't do much with the top without knowing what our function, what the formula for our function is. So we can't do anything with that. But we can simplify the denominator a little bit here. So let's make it f of x plus h minus f of x. In our denominator, because the x's here are going to cancel, we'll just have a little h there. Now let's get on to our main question of figuring out what is the slope of a tangent line to this curve here. Let's take a look at what happens as we let this small quantity h go to 0. As h goes to 0, these 2 points here get closer together. So imagine x plus h is now here. We've got this point there on our curve. And our line segment starts to look like that. It's a tiny little segment now. And in fact, the slope of that line segment is starting to look a lot like the slope of the tangent line at that point x. So as h goes to 0, the slope of the segment starts to approach the slope of the tangent line. And the way we can write that mathematically is to actually give a formula for the slope of the tangent line that involves a limit. We could say the slope of the tangent line is the limit as h goes to 0 of the slope of our line segment. So of f of x plus h minus f of x all over h. So this definition that we have down here, this is what we call the limit definition of the slope of the tangent line. And if you prefer to call this slope here the derivative, you could call this the limit definition of the derivative. So it is giving us a formula that allows us to find the slope of the tangent line, and we'll be able to do that at any point along our curve.